I'm not going to touch upon that. But I will try to do that, but then you can also see the video lectures that are available on that. Project, select, join, and all the union operators, relational algebra operators. Okay, but we can look at that lecture part of it. I'll arrange it required that part will be done for you. Okay, the video lectures will be, these video lectures will come to you from that. And the transaction processing part also, I'm going to be away for 2 weeks in the US, starting from October. So, what I'm planning to do is I'm actually planning to give the transaction. We already 12 lectures on transaction processing. I will actually ask them to play those lectures, and then I will sort of come for 2-3 classes for the question answer session. That's what we're going to do going forward. Okay. I'm going to do only the portions which are advanced, and all other things which are there in the video lectures. In my video lectures, I'm not going to redo those portions for you. Okay. That's what I have planned. So we will sort of make it more clearer for you as we go forward. Next class, there is an online lecture from IIT Madras for all the other colleges as well at the same time, 2 o'clock. Okay. This is for all those colleges that are part of the IIT Madras application program and for the database course, where there are 2 assignments that will be given. As I know, both Vasavi College, NIT Kadapalli and Partner Institute of Engineering and Technology are part of that certification program among the other colleges. So the 2 o'clock that lecture will be common for you and for those colleges next Wednesday's lecture will be common, which will be done from IIT Madras from a classroom for all the other colleges as well, not just for the Jntuk colleges, but it will be common for all other colleges across other places. Okay, right? There we will tell you about 2 assignments that you can do on the database course. Okay, both on normalization and how a full-fledged database can be modified, and then the assignments relating to doing that thing will be given in the next class at 2 o'clock. But that's whatever we are doing there. It's a common one. So I'll explain what we expect the students to do in terms of the 2 assignments plus 1 advanced assignment. That's mainly meant for the students who are part of the certification program of IIT Madras. Okay, but you can also do it. But then unless you're part of the certification process of IIT Madras, for which you need to sign an MOU with IIT Madras, you will not be evaluated. You won't take it. Only the university might want to do whatever it wants, but then we'll give you those assignments for you to learn. Okay, that's what we're going to do. Okay. Now let me actually go back to what I have been doing in the last class. So next Wednesday's class is going to be a common class, relayed by IIT Madras for other colleges as well. Okay. We'll tell you if there's a login credentials or something like that required, we will try to tell you that. Okay. No, that's okay. So let me actually there's something more I thought I will share it with you, but then anyway, that we can do later. Okay. Yes, I think just to recap what we have been doing, summarize this before I go forward with the indexing schemes and other things that are part of the key structures and all that stuff. We will just see what we've done in the last class and then try to review, recap what we've done and what we expect for the tutorial for you to do. Okay? The tutorial next week, Friday. Okay? Tutorial next Friday. Okay? I don't know the date. I think it is. I am actually probably traveling next Friday. That is 23rd. Okay? 23rd. September. Okay. We will see if I'm traveling to Bangalore on that day, then it will be on 24th. Okay. The tutorial is going to be either on 23rd September or on 24th September. But most probably it's going to be a 10 to 12 as we did the last time. We just happen further. Okay. And this will cover all the material up to the database design and then normal forms. Okay. We'll give you a tutorial sheet, a sheet of problems, and then we expect you to come prepared, and then we will start solving them, one after the other in the class. Okay, so that any doubts you have also you can sort of ask, okay, on these normal forms. Okay, the tutorial sheet possibly will be sent by Monday to you, or even before that. Okay. Then you can actually get prepared and then come for 23rd September or 24th September for the tutorial class on this. Okay. I'll just give the material that we expect you to come prepared for the tutorial. There's going to be another tutorial which we'll do on the transaction processing. Okay. These are the two important things. The other things like SQL and all that you will be getting anyway from your local colleges with the machines that we have. The SQL part we expect the colleges to take care of it along with the video lectures that are available. I'll show the video lecture link, okay, where the video lectures are already available, which you can use as part of the this thing. Okay. Right. Okay. And I'll just give I'll recap and then just leave you with what are the material which we expect you to study for this and what is the book that we are going to look at. Okay. The book that we are looking at here is text is the database complete database systems. Okay. The software and women and Jennifer. Okay. All of them are from Stanford. Okay. This and then the other book that I'm using is the Raghu Ramakrishnan. This is actually an alumnus of IT. Okay. These three people are from Stanford, so I'm using this book and the book by Raghu Ramakrishnan, especially for the indexing part which I'll cover now. I'm going to use the Raghu Ramakrishnan's book. Okay. The chapter that I'm in the normal forms from this book. Okay. The material I've covered also is largely, I think you can have a mapping to this book. Okay. So if you have any doubts, you can look into this book. Okay. Now the tutorial session will also come with problems, so you can actually look at. So to just give a summary of, is everything coming properly now? Okay. Desktop is not yet shared. I've already shared the desktop. Why is you saying I have not shared the desktop? Stop desktop sharing, it says. Is the desktop still not coming? Security, is the desktop not coming? Not coming. Since I've actually shared the desktop, I've stopped it now, trying to again share it, see if it is coming. Is this coming now? Is the desktop coming now? Loading now. Just check that and okay. Is it coming now? See, we have an internet problem today actually. I think our internet was unstable. Okay. Internet, there is a problem with our internet here, so, video lectures, and no, the local college will take care of that portion. Okay, right? So there is not much, it's much easier set to be done. So the transaction processing, again, I will come more often, but then since I will be traveling in the US during the month of October, from this end, I'm actually in the US for 2 weeks, so I won't be coming often as I was coming on a regular slot, right? But then I'll try to see if I can come. But then in my absence, the video lectures will be played. They're quite probably I look slightly different because they are recorded some 10 years back or 14 years back. Okay, so you might see me in a different way there, compared to what you see me now coming and doing the lecture. Okay. So what I'll do is I will come for a interactive session as a flipped classroom mode. I will ask questions and then sort of do them in the class. Okay, I do more problem solving in the 3-4 classes that I come, so that I can help you actually build the much more than what was there in the lectures there. Okay, right? That's the way we are going to go about this class. But the remaining 2 classes that I have, I'm going to look at indexing, look at the relational model indexing part. What are the different ways the file will get indexed? We started with file system in the very beginning, okay? And we in fact gave an assignment on read-write file systems. Okay, read-write using the read-write system calls, how files are read. So what we're going to do is how we can improve upon the file accesses by making the indices. Okay. I'll show in terms of the database. I'll go to the internals of the database. I'll show how the database. For example, I'll go into MySQL. Given a table, I'll show you what are all the other files that MySQL creates, and how you can basically understand the storage system of the database, and how the other things like locking will be built on top of it for the transaction processing. Okay. From now onwards, the course will become more database internal. We will try to understand the database processing. Okay, how database internals of the system, okay, database system, a little bit more. That will not be present in normal textbooks as well as in the video lectures that we have, and what is available in those video lectures. Okay, right? That's what we're going to do in the remaining classes that I have. Okay, become, okay, what you should prepare. Okay, is the desktop at least loading now and still not loading? Chakravarti? As the desktop sharing working now or is still not working? Just alert me if the desktop sharing is working. Then I think I can switch there and then keep doing the material in the desktop and then do a regular class. Okay. The desktop sharing is not working, then I have to continue this video mode. Still loading, still not. So that means we don't have still the network problem is still not solved. Okay. Still loading. Oh, okay. Okay. Then what we're going to do is in terms of the database design, what we did is we start with the relations. Okay. And we examine if there are functional dependencies. What you will be given is relations and the functional dependencies. In some cases, in the tutorial problem, the functional dependencies have to be inferred. For example, we give a relation, we expect you to make assumptions about the possible functional dependencies. In most of the problems, the relations and the functional dependence will be the starting point. Okay. Then we are going to ask you the questions like, now, what are the keys for this relation? Which means that you take attribute sets and do the closure on the attribute sets to see which are the candidate keys for that. There's a first thing that we expect you to do. We'll give you relations, functional dependencies, and we want you to understand the concept of attribute closures. Okay? Is that clear? These are the 3 things that we expect you to understand. given relations, given functional dependencies, first attribute closure. Okay? Given that you know attribute closures, you should be able to see the candidate keys for the relation. This is something that you need to understand. Okay, that's part of the concept. We expect you to understand. Once you know the candidate keys, then we get to the normal form. Given functional dependencies and candidate keys, we have to see first whether the relation is in BCNF. Okay, the relation for it to be BCNF, every functional dependency, the left-hand side has to be a super key. Okay, so you should be able to understand what is the key, what is the super key, and given a functional dependency, for every non-trivial functional dependency, the left-hand side has to be a super key. Okay, if that is then it is in BCNF. Otherwise, the relation will suffer into duplication of the data. Okay. Now, we also taught you TNF. The case where TNF, where the LHS, the relation can be in TNF if the LHS of the functional dependency, left-hand side of the functional dependency is a super key, or the right-hand side is part of the key. Okay, then it is in third normal form. Okay. Now, for completeness sake, we looked at second normal form and first normal form. Second normal form where the non-prime attributes are partially dependent on the key attributes. Then, no, we say that it is not in second normal form. Every relation will be anyway in the first normal form because it will be better. We expect you to thoroughly understand all the normal forms, but then practically we will be using only BCNF and 3NF as far as functional dependency is concerned. Okay? Right? Now, in terms of the understanding of the functional dependency, we also want you to understand the Armstrong's three actions. The reflectivity action, where basically the right-hand side is a subset of the left-hand side for the functional dependency. Okay? In which case we say it's a trivial dependency. Then the augmentation action, where you can add the set of attributes on the left-hand side as well as on the right-hand side. Okay, then we call that as augmentation. And the transitivity action, where basically if A functionally determined B, B functionally determined C, then we say A functionally determined C as well. This is called the transitivity action. So we expect you to understand all the three transitivity and all the three Armstrong's actions. Using these actions, given a set of functional dependencies, you can actually get more functional dependencies, deeper more functional dependencies. That's basically, at this point, we expect you to understand the closure of the functional dependency. Given a set of functional dependencies, the closure of the functions. Okay? This is something that we expect you to understand as part of this thing. Now, in terms of the design part, if the relation is not in BCNF, okay, Boyce-Codd normal form, then for bringing it into Boyce-Codd normal form, we can split the relationship into other relationships. For example, given a relation R, it can be split into R1 and R2. Okay? When you split a given relation into or more, for a simple case, we're taking that as split into two sub-relations, okay, R1 and R2. Now, when you split this relation, you have to worry about two properties. One is the split needs to be lossless. The same data that is there in the original relation should be preserved in the split also. Okay, this is called lossless decomposition. Given a relation R, it has to be lossless decomposition. For the lossless decomposition, you need a common attribute. R1 intersection R2, you need a common attribute between the two decompositions, and you need a functional dependency from that common attribute to either R1 or R2, some other attribute in R1 or R2. Then you are going to get the original data back. Okay, that's a first property. When you split a given relation R into R1 or R2, you want to get it as a lossless decomposition. This is a requirement. Okay? If you are making a lossy decomposition, then the original data will not be preserved. Okay? So you should understand what is the lossless decomposition. Okay. Yeah, we know that the desktop is not loading. For all those who are coming little late, please understand we have a data link problem on the campus, and then our internet is not completely functional. Okay? We can try it with the Google Hangout, but I am not sure whether I can get to switch to Google Hangout. There's no problem. Okay. Try Google Hangout. Okay. And fine if you want me to switch to Google Hangout. Okay. So I switch to my Google. Okay. Then I think I will I'll close it here and then switch to Google Hangout. Okay. Let's just give a few minutes to close this here. Okay. So given that a relation is split into the two sub-relations, it should be lossless decomposition. That is the first property. The second property is the dependency preserving. Okay. The dependency preserving property we'll talk when we get to the Google Hangout. Okay. Okay. I'm actually logging out from here now, and I'll go to my Google Hangout. Okay. If you are able to add all the attributes of the, I'm getting crosstalk. Can you mute please, all of you? Don't unmute unless you have a question. Okay. So given an initial set of attributes here, we can just look at how I think this is something that I have actually covered quite some time back, I think. Okay, this is, I'll just check if I have, for example, here, this is the one. Okay. Now, this is something that we will explain. For example, BD you can see. BD closure is given B and D, given D you can infer A. Okay, D functional determines A has come here. Okay. Now, given that this set has both A and B now will determine C. C also will get. So, BD closure is BDAC. Now, this is all the attributes of the relation are functionally determined with this initial set BD. Okay, BD becomes the key or super key. If B itself can determine, then it becomes BD becomes the super key. Can the attribute is B going to be a key for this? Is B going to be a key for this? Can somebody unmute and answer this question? Is B a key for this? Can any of the colleges unmute and then answer this question?
Yes, sir.
Right? B alone doesn't determine C. A and B will determine C. Starting with B alone here. B closer. So B is not a key for this.
Sir, we thought it is B
C comes when B
it's
comes.
not A. It's A B determines C means it will not.
B alone doesn't close because you need A and B to determine C. So B is not a key for this.
Sir, we mistook that as B determines C. We didn't see that A B determines C.
It's a AB.
Display is not there right now.
Okay. So this what they are saying is this is comma there. It could have confused you. Okay. Okay. Now is that clear? AB determines C here. Okay. In this case, B is not a candidate key.
Yes,
Okay?
sir. That's true.
If B alone determines C, what you are saying is correct.
Right, sir.
Okay?
We mistook
If
that.
this is the case,
Yes, sir. Right.
then actually B becomes, now the closure will bring in C, and C will bring the D, and D will bring the A. Okay? That's what you will get. Okay? Right. Okay. So, this is something that we want you to understand. What are the candidate keys? Given the functional dependencies, what are the candidate keys we want you to understand? Okay. As part of the second one, we want you to establish whether given that this relation, for example, in this case, it is AB, right? AB is determining C. So, the candidate keys are basically BD, as you can see, BD, AB, BD, and BC. These are the candidate keys for this. Okay. Now, to determine, next concept that we want you to understand is, given this relation and given these FDs, is this in BC and F? Okay. For this, the LHS of the every functional dependency has to be a super key. Here you can see that can see here AB is a key here, as you can see. Okay. So at the left hand side of this functional dependency is a key. Okay. Now if you look at C D, okay, C is not a key for the or super key for this relation. So suddenly this is not in BCNF. Okay. BCNF requires that every functional dependency, the LHS has to be a super key. Okay. So this violates, this FD violates, this FD violates. So this is certainly not in BCNF. Okay. So we want you to understand this concept. Okay. At this second level, we also want you to understand what is 3NF. 3NF is the case where the LHS is a super key or the RHS is part of a key. Okay. Now you can see all these are actually part of these keys. So these all become prime attributes now. Okay. Now in this FD, C is not a super key. Okay. The RHS is part of a key. D is part of a key here. Okay. Similarly, DA. D is not a super key, but then A is part of a key. So this becomes in 3NF. Okay. This is something that we want you to understand. Okay. First thing, we want you to understand the functional dependencies. We want you to understand the Armstrong actions, and we want you to understand the attribute process. We want you to understand the keys, and then we want you to understand the BCNF and 3NF. Okay, 3NF will cause some duplication because of these dependencies, functional dependencies. The left hand side not being a key will cause duplication because this could be repeated. This value could be repeated. Because this value is repeated, because of this functional dependency, this determines the value of D. This will be duplicated. Okay, right? So 3NF will have some duplication, but BCNF will never have any duplication of the data in the relation. Okay, this is something we want you to understand. Okay, right? And finally, when a relation is not in BCNF, how to bring? We are going to split the relation. This is where we were actually looking at in the last class. This is what to bring the relation into BCNF. Okay, because that's a good one. So given a relation R, for example, R, A, B, C, D, E, and F. Okay. Right. So whatever functional dependencies that they have, if you split this into R1 and R2, two relations, what you need to worry about is this has to be lossless decomposition. Okay. Besides this being, this R1 and R2 can be in BCNF. This may not be in BCNF. So your goal is to actually split this relation into, this is not originally in BCNF. So you might want to split the relationship to bring it to BCNF. Once they are in BCNF, there are going to be any loss. There won't be any loss. Okay? Right? BCNF, there are not going to be any duplicates. But what you have to show is, given this split R1 and R2, original data which is there in R is preserved by R1 and R2. Okay. Are there any questions? Somebody has unmuted. Is there any question? Okay. If you have a question, then only unmute so that I can stop. Okay. Right? So, this is the relational database design. First, you will determine, given this relation, given these FDs, you will determine which normal form it is in. If it is not in BCNF, then you want to split this relation to bring it to BCNF. So now, if you can split it into more relations. So R is, for simplicity's sake, I was splitting this R1 into R1 and R2. For example, one possible split can be R1, okay, A, B, C, and then R2 is A, D, E, F. Is this going to be lossless? Can somebody answer this question for me? Is this, whatever the functional dependencies are, is this going to be lossless or lossy decomposition?
It's a cross product, sir, because there is no common. Sir, this becomes like a cross product because you don't have any common attribute on this split.
Correct. So, what happens in this case is, if everything is, the whole thing was key, then possibly you won't lose. There are no functional dependencies at all. Then the original relationship is already in BCNF because there is nothing, okay, no functional dependencies. Then any split will not cause problems. But if it is not in BCNF, there will be functional dependencies in the original relationship. So this split, there is nothing common across R1 and R2. So this becomes a lossy decomposition, because you take a set of attributes A and a set of other attributes. There is nothing to actually combine them. As Professor Moocs is saying, this will become now a cross product between the two relationships. You can't join because there is no common attribute. Across whose values will allow you to bring the original records which are there in the relation back. Okay. What is the lossless decomposition? A lossless decomposition will require a common. For example, the intersection between R1 and R2. I can't put that symbol here. That's an intersection, set intersection. Okay, intersection R2. Okay. From this, you need actually a functional dependency to either R1 or R2. This is the property that you require. Okay. For example, here A is there, okay, as a common. So now you need a functional dependency from A to one of the other attributes. Then it becomes a lossless decomposition. Okay. Now the common attribute, from the common attribute, okay, you need a in fact, it's easy to understand also. You need something from this set, the remaining set. Okay, then it is going to be a B, then it's going to be R1, and if it is the other ones, you're going to get for the other one. So this requirement that R1 intersection R2 is not null. Okay? If it is null, then you will not be able to do this, right? In the other case, that's null. Okay? These common attributes are there, and then the R1 or R2. Then this is going to be lossless decomposition. Okay, right? So first requirement is, when you want to split a relation which is not in BCNF, you have to ensure that it is a lossless decomposition. Okay, this is a property that we want you to understand. The second property that we want you to understand is basically the dependency preservation. Okay. This is the other property that we want. What is the dependency preservation? there are some functional dependencies that are defined on the original. I think I'll take a new slide. Okay. So we have an F defined here. Okay, on the relation, there is a set of functional dependencies that are defined here. Okay. Now, what you want to do is the projection. You have an R1 here and you have an R2 here. Okay. Now, what you're going to do is you're going to do an F closure here. F plus is the F closure. Okay. F closure will include all the functional dependencies that can be inferred given the initial set of functional dependencies. The trivial ones can be ignored. Okay. Right. That's a F closure. Okay. Given that there is an F closure, we are going to project F plus on R1. Okay. Then you get, let us say, F1 plus. Okay. Okay. So all those dependencies, considering the attributes of R1, are the F1 plus. Okay. Similarly, project the F plus. Okay. This becomes an R1, which becomes F1. Okay. Similarly, project F plus on R2. Okay. This becomes F2 plus. Okay. Now, what you need is, if you have F1 plus, okay, union F2 plus union, and closure of this whole thing together. Okay, whatever additional things that can be inferred as part of this. Okay, should be the original F plus for the dependency preservation. This is a rule that should be satisfied for the relation split R1 and R2 to be dependency preserving. Okay. What this shows is all the original dependencies that are there on R are now preserved on R1 and R2 when you split this relation. Okay. This is a desirable condition. When you split relations, if the dependencies are not preserved, what happens is you have to do an additional work of combining both these relations, joining these relations, and then enforcing this dependency on the original relation. Okay, this is going to be very costly. Okay, so dependency preservation is desirable. Okay, right? Normally, if the dependency is not preserved, given a relation R, if it is not in BCNF, you can split it, get both these properties, both the lossless decomposition and dependency preservation. You are going to split them. Okay. In case you are likely to not be able to preserve the dependency by splitting, then what you are going to do is you are going to leave it at 3NF. You are not going to go further. Now, if a relation is not in 3NF, it is in 2NF. Okay. A 3NF requirement is there are no dependencies across the non-prime attributes. Okay. If there are dependencies, you can easily take them out. Okay, because they are not keys. You can easily take them out and then make them into a separate table, keeping the dependency and making that into a key. So this problem will not come. So 2NF can be easily made into a 3NF, but then there is a possibility that if you want to achieve a 3NF relation into BCNF, you might actually run into problems of dependency preservation. In such a case, you will stop at 3NF and you won't go to BCNF. Okay, given the functional dependencies. We are assuming that there are no multi-valued dependencies. If there are multi-valued dependencies, then you have to do 4NF. If there are joint dependencies, you have to do 5NF. Okay, generally, that won't be the case. Okay, if they are, then you have to deal with them in your relational database design. That's a comprehensive treatment of the whole relational database design model. Okay, how we are going to do the relational database model design. Okay, the tutorial is going to give you some problems on just what I had explained, and make sure that you are able to do all of this, and then you are able to solve the problems of the relational database. tutorial on. Okay, right? Is that clear? So if you have any questions on this, you can ask me now. Okay. The tutorial sheet will come possibly by Monday. Okay. Right. Are there any questions? Further questions on this? Okay. This is very important that you understand the relational database design. Okay. These concepts are very, very important and they're fundamental. So if you understand them, you will do a good a table design for a given problem. Okay. This is fundamental. So coming up with good table design is fundamental to database design. Okay. Right. Okay, I'm assuming that there are no more questions here, but then we will solve more problems, as I said, on the Saturday, 24th Saturday on database design. Okay, right? Okay, so if we have no more questions, I think I'll stop here for this lecture. Okay, and then I will, as I said, I will come back to you on the assignments part, doing the practical assignment part on the database design. In fact, the questions, practical design questions will test you in terms of making changes so that the database design becomes better. Okay. Those three problems we will give you next week. Okay. So that I'll do it on Wednesday, okay, 21st at 2 o'clock. Okay. And then a tutorial on 24th. And then get out the indexing. Okay, how the table indexing will happen, and then what is the hash indexing, and then what is the B plus indexing that we need to do. Okay, and show you how we will use for doing efficient joinings of the tables. That's what I am going to show you. Okay, as far as the relational SQL statements and relational algebra is concerned, and now project, select, join, natural join, semi-join. So in fact, I'll probably can be a quick class on relational algebra models. Okay, maybe next half an hour I'll just do the relational algebra model. But the only problem is I can't get all the symbols on my thing. Okay, if I have a board, I can easily do it, but then I can't get those symbols on my PPTs here. So I'll have a problem actually doing the relational algebraic operations on the maybe I'll just take a simple example and explain. Hello? 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 Yes. Is there a question? We can have an interactive session if you want. Okay. Yes. I'm seeing someone here on my screen. Which batch is this?
Sir.
Yeah. Yes, audible. Yeah.
Sir, actually, I have a doubt.
Yeah.
The table we have primary keys existing. The table for a long time, and suddenly the Aadhaar card and all are coming, and that has to need a primary key. And how should I maintain my tables then?
Oh, see what we are asking about, if the whole thing changes now, Aadhaar card comes in, and then Aadhaar card now, and the bank accounts are now linked to Aadhaar card, right? So that becomes the primary key for most of the data that we have, and then everywhere the Aadhaar card becomes the primary key, because no two people are going to have the same Aadhaar card. Okay. So that requires a complete redesign, and then the functional dependencies will all change. So you will end up now a new version of your database design. The original one will completely change with the Aadhaar card introduction. Okay, right? You have to redesign it. Yes.
Sir.
Okay.
Sir.
Yeah.
Before the Aadhaar number becomes the primary key, perhaps you might have defined some other thing as a key.
Yes.
But so that becomes just an alternate key. Just you can change the Aadhaar ID to, because you will not be losing any data. So the table structure can be altered with the alter structure, and include Aadhaar card so that you will not lose data, because you can preserve the entire data, but additional dependencies will come into picture. So it may
Yeah.
not be a big issue to redesign it, sir.
Yeah, I see the basic thing here is I agree with you. Only thing is one has to examine what will happen with the Aadhaar card activities being introduced. Because now most of the differential integrity may be specified with Aadhaar card, okay? Differential integrity constraint, and then they are across. Similarly, if you have specified something else as a primary key, all the indexing would have been done on the primary key. But now the retrievals, all retrievals may happen mostly with the primary key and the Aadhaar card number, not as the other ones. So the indexing also would have changed. The internal indexing also has to be changed.
Because, sir, once you
Okay.
declare Aadhaar
So
ID as
it
key,
depends on how much change this will introduce into your system, depends on what are all the other things that are going to change. Okay?
sir, I agree. Because if you make Aadhaar card as primary key, you need not have a separate index, because once you declare primary key, it is automatically indexed.
Correct. Now, if there is something else as a primary key, all the indexing would have been done for that.
That indexing will be dropped, sir.
Correct. So this new index has to be built now.
So
Okay?
we have to, yes, sir, we have to build that index if required.
Correct. That change will happen
That
into your
change will
system
happen,
now.
sir. Indexing
Okay?
is concerned.
Whether it is a small change or whether it is going to be a major change, whether it can be handled easily or not, depends on, for example, if there is a bank database that needs to get changed now, it may not be a simple change. So I don't know. The whole thing has to be looked at
Of
carefully.
course, sir,
Okay?
that is true, sir. But basically, it may not be that difficult, I am saying.
Yeah, I didn't get your this thing because I think your phone is muted. Yeah, I think your speaker. Yeah. Can you just now speak?
Sir, I perfectly agree with
No,
you.
it's still not audible. Yeah.
Sir, I perfectly agree with you, sir, because unless we examine the total data, we cannot say things.
Yeah.
But Aadhaar being an augmented one, I feel it may not be that complicated. It could be laborious, but may not be complicated.
Yeah, I don't know. See, it depends on now. For example, the bank account being linked and your LPG cylinder thing being linked to it. What are the issues that are going to come in? I don't know. Okay.
Yes, sir,
You suddenly don't want to pay a person twice, okay?
Of course, I agree.
Because your database design is wrong. For the same cylinder delivery 2 times, you don't want to pay the subsidy back to the person. So there are going to be referential integrity requirement that needs to be enforced.
Of course, sir, that is essentially there anyway.
Yeah, one has to examine it, carefully. So this is a change that's any version management change, database change. What we were talking is how do we design database from the beginning? Given the ER model, how do we design? Now what happened is after you had put all these databases, something got changed. So it will require all the changes to be re-looked at to see if anything else has to be changed in your database. Okay? But it's a good thing to do. If somebody has a project looking at Aadhaar card, okay, some projects relating to that, they're good projects to be looking at. Okay? Including, I understand Passport Office is also looking at that problem, and everybody is looking at it.
Yes, sir, that is true.
Yeah. Okay. Any other question you have? Yes. Other questions? There's one student who was asking a question. I don't know who was the student who was asking the question. Okay. See, relational data model is only one of the models. All these concepts will fully change, completely change, because there is nothing like a relation and a tuple. What we are going to talk about is largely object models. There's an object, and then an object ID becomes the way you're going to go and access that object. So if you're talking about, this is an exercise that I gave to students. One of the students sent me an email from Kakinada Engineering College. I gave one assignment to this college student asking him to look at the Twitter database and then take the tweets and store them. Has the student done that? I'm curious now. Which student I gave this project? there is one other student who sent me an email, can I also do that project? Okay. When I gave a project to one student, it doesn't mean it is only just for that student. Anybody can do. Who will stop you from doing a project? Okay. This is something that you can always pick and do. I think there is one more student who sent me an email whether they can do it. Okay. Now the question is, this is an additional problem that I'm giving it to you. Okay. We don't teach you much, but we'll see if any of you guys can do this. What I want is, as the Twitter feeds are coming in, it is going to be a JSON object. Okay. The Twitter gives you a JSON object. Okay. All that you have to store is, in a given day, you get about few million tweets. Okay. And you have to store these few million tweets, okay, into a JSON objects, which is something like a MongoDB will let you do. So you look at that. What I want you to do as part of this course is store them in your MySQL database. Tweet ID and the entire tweet text that is coming in into your MySQL database. All that you will do is just a relational table, tweet ID and tweet text. Okay, as it is coming in, you're going to store that. Write this into your MySQL relational database. Okay, right? If you are able to do this, please send me an email. I want to catch you and give you more interesting assignments. Okay, right? If you are able to do this, please send me an email, because what we want to what we want you to is my is my desktop coming or not coming?
So we can see your desktop.
Okay. This is something that we had actually coded. I think I will show you the next class. There is a program that was built to just take the okay, this is something interesting that actually uses underneath a database, okay, with lot of as the incoming data comes in. This is an IIT Madras project, okay. What this project does is, as you can see, this is a tweet to June project. This is we are incubating a company in the Silicon Valley on actually looking at the social media, okay, how the social media monitoring can be done. For example, you can say here track custom keywords, okay, and you can enter this information about, for example, here it will give you as the tweets are coming in, okay. We can say that I want to track all the keywords. Okay. Hopefully now you can see all the as you can see in this dashboard, it gives you the live feeds that are coming in. Okay. There are actually about 600 million tweets that will be coming in a given day from Twitter. Okay. Now this whole set of tweets will be stored in, and you can do a lot of analysis. Okay, now we can see here how many total tweets came, how many retweeted, okay, what is the percentage people are retweeting it, okay, and then you can also get the language information. How many people, for example, here, how many tweets are positive? We do sentiment analysis on the tweets, and we do actually sentiment analysis and say how many are positive, how many are negative, how many are neutral, and things like this, okay. It also actually, as you can see, it will give you a hashtag, top keywords in the cloud, whatever are actually currently the top words in the cloud, right? This is actually done for a language, specific language, okay? It can be done for English. When you choose it, you get the corresponding Google Trends. You also get the, who are the most influential, users, who are the most active users, okay? You can do a lot of analysis on this, okay? And where are all the tweets coming in, the location of these tweets. As it is happening in the real time, you can analyze all the tweets coming in from multiple places, okay? And also you can look at, lot of analysis. You can do phenomenal analysis in terms of, for example, you can say how many people in the world are positive, okay? Given this, roughly you can say about 85% are neutral in the world, 10% are positive, 5% are negative. Now, why I'm giving this is a very good case of how do we develop databases. Okay. Now, one of the things is as this data is flowing in real time, huge amounts of data is flowing in real time. How do we store this data into a system? And then what is the kind of analysis? For example, here we do a lot of real-time analytics. Okay, we run the big data analytics on this data that is coming in, because you want to see now who are the most influential users. Given a keyword, you want to find who are the most influential users, okay, things like that, okay, or who is the most retweeted person. Things like that become extremely interesting. Now, these are different kinds of databases. These are not the traditional databases. What we have done is a relational model, okay. Here, most of it doesn't fit into relational model, the traditional relational model that we have looked at, okay. This requires a different model. In fact, this is what is called now the, this is all unstructured data, right? NoSQL databases. What we have studied so far is the SQL databases. What is becoming most popular is the NoSQL databases, because billions of data, terabytes of data. For example, the Google Earth, okay? We've seen the Google Earth, okay, which is the data about all the places in the world on the map they store, okay, and when they navigate, they show the routes on the Google Earth map. The database is not the relational data model underneath. There is something called HBase there, okay, which is built on Google File System, GFS. That's why file system becomes the underneath storage system. On top of it is the database system that is built. In the case of relational database, the file system, on top of it the storage service. The storage service is the table, the indexing, and the schema. These get stored into the relational data model. But it becomes a Google file system. Google file system is completely different file system. Okay, it's a cluster file system. They are chunks, and they're chunk servers. So this Google file system stores data in a different way. And the HBase, which is the okay, their database is called the big table. The big table is built on top of the Google file system, GFS. Okay, big table is used for storing the Google Earth, the old data about Google Earth. That's what is used for the maps now. If you look at all the Google Maps, that uses underneath that Google Earth, which is also called the big table. The open source version of it is called the HBase. HDFS, Hadoop file system, is the file system. On top of it is called the HBase. Right? So this database field is becoming extremely exciting now because of the amount of data which we call as the big data, which is something is very exciting. As you can see, as the data is flowing in, I'm just showing this thing, a lot of data that is flowing in. For example, you want to analyze the language information of the tweets. Okay, so many things you probably want to do. Okay, if you people are familiar with the Arab Spring Revolution, okay, now one of the things people want to do is predict if there's virality. Okay, right? If a tweet is going to become viral, why do you want to see if a tweet becomes viral? The tweet becomes viral. Okay, you want to see the whole Arab Spring Revolution happened by one guy, disgruntled guy, sending a tweet saying that let us meet in the evening. a few million people met that evening, and that what brought the government down. Okay? Now the databases are getting into a new wave of excitement now. Okay, now we want to find out if the tweet is going to become viral. Okay, we want to have all the community detection, everything as part of the storage. First thing is, how do we store this massive data? That itself is becoming a big issue now. You know? The traditional ways of storing data is changing completely in this new context. Okay? And the kind of problems that you're facing in terms of doing analytics is completely different as far as this data is concerned. You know? Right? So there are exciting opportunities when you're doing the database research. You know, suddenly Professor Moocs will also tell you there is so much of exciting research that one can do in this space, and a lot of job opportunities. For example, if you actually built this system for us, are all interns who came from various colleges. Okay, right? Excellent guys. That's where I'm telling you now. This simple exercise of getting the API, the Twitter API, and reading the tweets and storing them into a relational model will open up a lot of opportunities for you for learning. Okay, then you see why this model is. Though we are teaching you relational model, for a lot of applications, common business applications, relational model is a de facto model. But there are new exciting applications that are coming with the digitization of data, like what we saw just now, Twitter data, right? There are lots of such data. Sensors are throwing data. Google Earth, okay? Even the email boxes, the way they're getting stored is completely different now. Okay, Gmail data, the way they store the Gmail data, okay, is completely different. There's so many exciting problems in that domain, and it will be very interesting for you people. Though we're dealing with only a subset of the problems here, I'm going to give you a few interesting lectures as I go along. This half-an-hour lecture is to just open up your thinking, to all the dimensions that are existing there. Now look at, for example, the email boxes. That's also some kind of a database. It is actually distributed across multiple locations in the globe. Accessing them, keeping them consistent. Okay. For example, all the time keeping consistency of your email box is again a very, very big problem. We're going to look at it when we go into transaction processing. We don't want to lose transactions that happen. Okay. Now with mobile transactions, with mobiles being used for doing the transactions, it becomes a much more challenging exercise as far as databases are concerned, because people could be using their mobile phones for doing real-time transactions, but at the same time they don't want to lose any money. Nobody would like to lose any money. Nobody would like to have a transaction, the same transaction you pay twice. You're booking a railway ticket, you want to pay only once. But now most of us book the tickets on the web, right? Whatever happens across, you want to ensure that you are charged only once for the ticket, not twice for your ticket, right? There's so many interesting problems there, which we're going to see. Okay, I think this is an exciting story. What I'm trying to tell you is an exciting story. What you people should do is just see if any of you are able to just do this exercise of getting the Twitter feed and storing it into the MySQL database. Okay, please send me an email. I'll sort of work with you to give you more interesting problems on which you can work on. Okay, right? Yeah.
Sir, a small query, sir.
Yeah.
Sir, can you elaborate the importance of instantiated views on NoSQL database, sir?
Okay, but that I think we have not touched on the NoSQL database at all for these people. Okay, so I know that what you are asking, since you are at a different level, you are asking that question. But then first we have to teach them the views and all that stuff. What is the view? Also, I don't think these students have taught them. Let me see if I can simplify the NoSQL part of it. Okay. See, the key thing in SQL is you have tables and you are joining them. Okay, right? That is a key operation as far as databases is concerned, relational database are concerned. The whole idea is you store one fact at one location don't duplicate the data because it will create update anomalies and other anomalies. The basic understanding of relational database design is one fact at one location. Now, every other data is actually constructed, required data by the application is constructed by joining the tables. Okay, that is something that's why the SQL becomes important, because how your query planning, how your query planner is working. Tables for you when you are actually working on your queries. Okay, right? But then one of the prominent thing with the NoSQL approach to things is that you never do any of this. You know what you're looking for, and you go and then pull that. This is like you never need to join things as far as the application is concerned. Okay, so everything. For example, if you look at a database like Cassandra, the basis for the whole Cassandra, is that you have a key value store. The whole thing is just a key value store. So what you do is you only retrieve, given a key, the corresponding value that is there in your database. You never do any joins on top of it. But this requires that you know what you store in your table, okay, and what you retrieve from your table. Okay, you never do a join as far as that is concerned. Right? Yeah, you can come. Yeah. Just give me a few minutes. Yeah. So the whole idea of I think I'll sort of expose them to the NoSQL we are designing in the last few classes at the end. In fact, I'll show them a corresponding Cassandra database design, expose them to show them how a NoSQL database design would have compared with an SQL database design. Okay, right? But I think beyond that explanation, I don't want to give. It's basically what you will get in the NoSQL case is it's a key value store. Now, and you know what you're looking for, and you'll never need to actually join tables to produce the data that the application is asking for. Okay, right? So that's a key thing as far as NoSQL databases are concerned. Okay? That's why they are also called NoSQL databases. People don't like the term, especially the old timers, who are wedded to it. In fact, some of my friends who are so much wedded to SQL, we don't like the term NoSQL databases because they're so much wedded to it. Okay, right? But then, the younger generation, whom I work with, they're so happy with it, including my daughter, because the only database that she would like to use is only Cassandra. For the huge, streams of sensor data that they get, they actually put it in Cassandra and do analytics. Database as far as I can see. But sometimes I joke with them. Some of the data that they use, these systems are built, they use MySQL underneath. Okay, right? So, so it's a question of somewhere. This is like people looking at what sometimes happens is if you know a hammer, everything has to be a nail for you. Okay, right? Now, people who know NoSQL databases want to actually only use NoSQL databases. Okay, right? People who know a relational database want to put it everywhere a relational database. This is like a hammer, so everything better be a nail. But then there are small screwdrivers, and when you want to open up a small this thing, a very small screwdriver, what it can do cannot be done by a big turn key stuff. So you suddenly don't want to kill a mosquito with an AK-47, right? AK-47 rifle. Okay, right? So I think for a mosquito you use your hand. For a terrorist you will use an AK-47. So each one has its use. So in some sense, people have to understand what the tool is meant for and use the tool for the right purpose, right? So I think that's something that should become part of the understanding of the learning that happens for the students. Okay, right? That's also the same case. If people are exposed to the PHP and things like that, they don't want to. They think PHP is everything. Okay, They don't want to actually write programs in any other language. Okay, it will better everything be PHP, and then they become so wedded they argue for hours together why Java is a useless language and then PHP is so good language. It's the same problem. For me, it's the same problem. What things you can do in PHP, some things you can't do. Now there are frameworks that are coming in, excellent frameworks that are coming in for web programming. Okay, right? People should be alert to it. In my opinion, they should be alert to it, and then they should know underneath conceptual base. Generally, they will become employable. Okay. Otherwise, they won't become employable at all. This is something that I want to tell the younger generation. Okay. We better unlearn, learn. Okay. Unlearn to learn. Okay. Most of us do this, but we know the conceptual base. The basic conceptual base doesn't change much. Okay. But then, a lot of things that are coming in make things so easy and faster. So you better use those frameworks when you're building stuff. Okay. Right. I will show some of it. A little bit of it I'll expose to you in the course. The idea is you should be alert and you should be willing to learn many of this. And you be, most of them, if they say that, oh, I've done only this much, the industry is moving fast. So the most important thing is how do you apply this concept and then learn the new thing and make yourself employable. That's very, very important as far as the current students are concerned. Okay, right? One of the approaches that I'm using in this class is also a little bit expose them. Do the concepts, but then also expose them. Now today we did almost half an hour, 45 minutes of an excitement part. Expose them to something more than what is there in the textbook kind of an environment. Okay, right? Okay, I think I have another meeting to catch up now, so I'll stop here. Come back at 2 o'clock on Wednesday. Okay. Okay.